Yeah, welcome from my side as well. I have some company slides at the beginning. I'll skip over them real quick. If you're interested, download the PDF file out of your app, and you can look at all the numbers. But in general, Audi, we are a car manufacturer. So we are to some degree using what you're producing. Our electric vehicles, not anymore. We have some history, and we are part of the VW group. What you may not know is that within the VW group, Audi is the head of the what we call brand group Progressive. So Lamborghini, Ducati, and Bentley belong to the same Audi brand group Progressive, where we steer those companies. These are some numbers, and now we're getting to the more interesting things. These are the sites worldwide where we produce cars or motorcycles out of the brand group Progressive. So this is like the first step where we come into place as Audi production, and I'm part of the Audi production to evolve and drive the way we are building our products. So, as always in production, the cool stuff is what we're producing. Our cars are the cool stuff. That's what you should know or are supposed to know. Nobody cares on how we do it. But the real thing is that production is like sports. You always strive to be better than yesterday, to build better products ever more efficient. And our vision of the 360 factory, of our strategic vision, is pushing the limits of innovative and sustainable production. That's what we strive for as production, going there and really pushing the limits. Why? Well, because we want to build ever more productive and ever better products for you to drive. And since, I don't know, this slide could probably be from any one of you. This Industry 4.0, IIoT, however you want to call it, has been around now for, well, I know about it for at least the last 12 years, and I'm in that area. And what it promises is that with adding more sensors, getting more data out of your processes, we will be able to automate and optimize our processes with software algorithms. That's the promise of this vision. And we say, hey, yes, this is where we want to go. And 5 years back, when I was here, we were at the point where we realized if we want to do this and we add a new sensor, and with this new sensor comes new compute, and with this new compute comes another IPC that we have to install into our factory, we'll run into a maintenance nightmare. Who on earth is going to maintain all of that compute assets that we have on the shop floor, distributed across the entire plant? Next question is, how do you invest into that compute hardware? We all know that compute hardware ages much quicker than a robot. So there was a big challenge for us to figure out what to do. And back at the time, we talked with Intel and talked with them, hey, how could you do that? And I presented here, and this is a slide from 2020, our vision on how to do this, to actually virtualize the controls and get everything into a local data center that is capable of handling this. And we found the right partners to do that. So what did we do? First of all, just for the basic concept, I put a drawing of a robot here. Just think any kind of automation. In this IoT world, we usually think of cyber-physical systems having the compute attached to this cyber-physical system. And this is, quite frankly, what all the vendors out there want to sell us. They come like, hey, I've got this really cool new camera, and it can detect kinks on your outside, on the bonnets. and we'll show you where you have to rework because something happened there. And all you need to do is plug it in, and then we'll send the data up into our cloud. We'll process the data, we'll tell you what to do. And this always leads to the point, okay, how do we do cybersecurity with that? How do we update that camera? How do we maintain this system? And there are thousands and thousands of propositions of doing that, and all of them sound really good. And the problem that we face later on in production is now we've got thousands of vendors with thousands of pieces of equipment, and we have to maintain and do updates on every single one of them. How do you do it? And so what we came up with was thinking about cyber-physical systems differently. Why does the compute have to be attached to the physical hardware? And the answer to that is, well, latency. You have to be right next to what you're steering, what you're controlling for it to work. Otherwise, you won't be able to do it. And so we worked together with some really amazing partners. At that point, the networking part was Cisco. The virtualization worked with VMware and Red Hat for the containerized parts to figure out, okay, how do we build a hyper-converged infrastructure with real-time applications that is able to control physical assets in our factories, but the software running on this hyper-converged infrastructure. And so one key thing there is this red line. We have to have a real-time network. A network that enables us to, in our factory, we run Profinet RT, Profinet real-time, but it could be any field bus protocol. We have to tunnel this field bus protocol through a layer 3 network and still keep all the latency stuff working that this field bus protocol requires. Then getting that data package into the hyperconverged infrastructure, tunnel it through the hypervisor, get it to the application, have the answers, the stuff running back. All of that had to be developed. And so this is what we, together with our partners, we put our head down to do it. And we were internally able to change this paradigm of automation that we feel that is still there and is still out there. And that paradigm is if in automation, if I need a specific function, I buy a box that provides it. And we were able to change this to, if I need a specific function, I buy a software that provides it and runs in our virtualized or containerized environment. And so this is a picture of a typical production line. And what you see there, two parts, you see all of those silver boxes with those monitors attached. Those are IPCs whose sole purpose it is to drive that monitor. Yay. And then the left cabinet is purely there to drive that PLC that's in that cabinet. And so we started with 5 applications where we said, okay, we want to get rid of most of our IPCs, and we want to tackle the problem of a PLC or virtualize a PLC with still level 3 safety, because that's the hardest thing to do. If we're able, together with suppliers that believe in the same vision, to virtualize a PLC with still level 3 safety, there's only very little left where we then will say we won't be able to virtualize that. And then, so we talked to the people of Codesys, who shared the same vision, and Siemens as well. And now they did a really fantastic job. End of last year, those PLCs were safety still level 3 certified. So now we're at the point where they can actually be used in real production. And so what we did was, again, I said, take some software applications that get rid of the IPCs. So in the final assembly of a car, there are a lot of screws to be tightened. And if you want to have your seatbelt buckle tightened, you want to make sure it has the right torque with which it was tightened. That software belongs to us that controls the overarching screwdriver. And so we said, okay, let's virtualize that one. Let's virtualize our worker guidance streams, our MES system. And the third one is our diagnostics and quality control system. Let's virtualize that as well. If we do that, we get rid of almost 80% of the IPCs that we have in the final assembly. That being the first step. And then tackle one of the most difficult problems, virtualize the PLC as a door opener to show, hey, we can actually go where, what I showed on the last slide, we can actually detach critical compute from physical assets and run it in this hyperconverged infrastructure. And so our production line would look like this. We still have the screens, but we don't need that compute anymore. That was the vision. And I'm out of the technology development. Oops, sorry, didn't want to hit on the microphone. I'm out of the technology development. So we're the bunch of nerds who get to play around with stuff. And so we started this project in the P Lab, in the incubation phase. Actually, we started in 2018 with the first things. It took until 2020, and then we decided, okay, this is doable. And from there, we took the project out of the technology development. We founded its own project house, its own organization, IT and OT together, to accelerate and scale this out. And that has been the winning factor for us to jointly, together, IT and OT drive this. It came out of the production, the idea, but now we scale it out jointly. And so what we're doing, or what we managed to do, was basically set up this, what you see here on the slides. We have our automation cells. I'm talking about the automation part there. And we've got Profinet real-time, which is then tunneled via PRP over VXLAN into this hyperconverged infrastructure, which is still running on-premise. It's still running within the firewall zone of production. And you have to do it that way because a jump through a stateful inspection firewall costs you 1 to 2 milliseconds. And that will kill your real-time requirements. So we have that running. We've got the VPLC set up. We have a PLC without safety running since February 2024, and we haven't had a single glitch yet. So the next step is now taking the PLCs with the safety certification and put them into production first of all, again, we're taking this a little cautiously. So we're taking this into our Böllingerhöfe plant first, which has a low-scale production. We only produce 30 cars a day, long takt times. If something happens there, we won't be executed right away. So we'll take it there and we show that it works. And then being sure that this will work, we'll take it into a pre-assembly of an upcoming car project that is coming out of Ingolstadt, which will have the scope of building 3,200 doors a day out of this door manufacturing. And once we've proven that that works by the end of the year, we will then scale it out into our body and white shops and all the upcoming refurbishments that we're doing. So what have we achieved? 5 years ago, we said, hey, this is the vision. And now I'm here, I can say, hey, we did it. We actually did it. We have platforms set up for the Böllingerhöfe and for our Ingolstadt plant. We've got 600 IPCs virtualized. And we're at the point where actually we have more demand for people from the assembly coming and say, hey, I've got these other 1,000 IPCs over there. Can't you virtualize them as well? So we have to slow it down a little bit so that we can handle it. We have this platform high available with the high availability features of a hyperconverged infrastructure. in multiple data centers so that we have failover. And that at the same time gives us the ability in the future to do updates without shutting anything down. Because you can update one instance in the one data center side, then once that update has finished, switch over, update the other data center side, and yes, for that time you don't have the catastrophe failover feature, but you have enough people there to handle that. So we will be able in the future to do updates to our softwares and to our PLCs while the process is still running. We meet the new security requirements that we have. If you have a hyperconverged infrastructure from the IT point of view, it's really easy to do auto snapshots, to do rollbacks, all that kind of things. How do you do an auto snapshot out of your PLCs that are somewhere in the field? There's this thumb drive and this guy in maintenance that walks up to it and draws a backup once in a while. So all of that functionality comes right out of the box by using modern IT technologies, where from the automation point of view, we were completely ignorant that they exist. And the last thing on this slide, which was I think really important for this project to go through, we, together with the development and the rollout of this platform, we set up our own operations team that controls the full stack from the hyperconverged infrastructure through the network to then the applications. And from an IT point of view, only the applications are actually belong to production. All the rest, network, hey, that's ours. Hyperconverged infrastructure, yes, we as IT know how hyperconverged infrastructure works. And then telling them, yeah, but we've got 24 milliseconds time when a glitch in your hyperconverged infrastructure, if the glitch is longer than 24 milliseconds, will stop production. And that is a scary thought. So we managed to pull all these people together from IT and OT to operate this infrastructure in the same team that's scaling it out and still developing the last thing. So we're doing a DevOps like you would know from software, but a DevOps in the meaning of, hey, we're operating physical stuff here. And then, so what's to come? The next, what we'll set up is we'll scale these platforms we've set up in the Böllinger Höfe and we'll set up in Ingolstadt, scale it out to our third German production site, to the Neckarsulm plant, and show the last proofs that this end-to-end stack is really fulfilling the Profinet RT time with 1 millisecond latency max, and then deploy the VPLCs, as I said, in Böllinger Höfe first. I think that's going to happen in March, and then this summer in the Ingolstadt plant. So this is the incredible journey we've been on, and it's a door opener for many things to come. Now we have this platform installed, we have a hyper-converged, real-time capable compute infrastructure, and now think about all the things that could be done. Everybody's talking about AI robotics. Well, this is cool. We are going to build a new car manufacturing line. Well, actually, we're always building new car manufacturing lines, but we're building a new car manufacturing line. We're going to buy the robots probably this year for a line that will then go live in 2 years. What do I have to do in order to make these robots AI ready? I don't know. Nobody knows. No, not even the robot vendors are able to tell us now what in 3 or 4 years software will be able to do and what hardware requirements you're going to have in your physical hardware in order to do all the cool stuff that will be out there in a couple of years. So how do we make a sound decision on what kind of hardware we're going to buy? And the answer is, Well, if we manage to detach that part of the software from the actual hardware and run this on the hyperconverged infrastructure, that is scalable. If we need neural processing units that will come out in 2027, well, yeah, then we'll add them in 2027 because they're not here yet, but we don't need them today, so we don't need to add them. And this is the entire idea of the transformation journey we've been on in order to really drive the efficiency, harness all the stuff that this industrial Internet of Things, that Industry 4.0 is promising us, without being tied down by hardware, without going into or getting into maintenance nightmares because, hey, a thumb drive and sneakers is the network that you need in order to do backups and updates. So this is the end of my presentation.
Okay.
Thank you for listening.
Thank you very much.
Looking forward to your questions.